Welcome to this Edexcel Further Maths Statistics 1 video, Introduction to the Negative Binomial Distribution. Just as with the binomial and with the geometric distributions, with a negative binomial distribution, the probability p at each independent trial is constant. The random variable x, where x follows a negative binomial distribution, is the number of independent trials necessary until r successes occur. And quite clearly we cannot have r successes until we've actually had r trials. And you may find in books that you can see this notation being used: x follows a negative binomial distribution with parameters r and p. The negative binomial variable x, just as with the geometric variables, has a theoretical infinite number of possible outcomes. Theoretically, we could be waiting forever until we achieve the r successes that we're wishing to find. And you can think of the negative binomial and the geometric distributions together and imagine the geometric distribution as a special case of the negative binomial where r equals 1, because in a geometric model we are looking for the first success only. The definition of the negative binomial distribution is quite more complex than the distributions you have met before. The probability function px equals x involves, and you can see in brackets there, x minus 1, r minus 1, and at the bottom of the page here you may be more familiar with this notation, and certainly on a calculator that's the notation you will use, and that's the notation you've been familiar with when you've worked with the ordinary binomial distribution. So the negative binomial involves how many combinations of events can occur. P again is the probability of a success, so we are having r successes and x minus r failures. And you'll notice that there are two parameters involved with the negative binomial distribution. We have p, the probability of a success, and r, the number of successes. And note that the first outcome possible for x is r. So on this slide there are a couple of examples of situations can be modelled with a negative binomial distribution, and you might like to pause the video at this stage and just read through both of them and have a think about them. If we look at the first example on this page, clearly r equals 5 because we are requiring 5 heads to be obtained, and p would equal a half because the probability of getting a head or a tail is a half, and our random variable x would be the number of times a coin has to be flipped before 5 heads had occurred, and x would follow a negative binomial distribution with parameters 5 and a half. And do remember, as I've said before, if you're setting out a solution in an exam, it's very good practice to identify r, p and x and actually state what they represent. In this second example, quite clearly p, we are told, is 0.4. The probability of a success, the probability of finding a person who attended the last home game is 0.4, and this time R is 10 because we require 10 people who attended the last home game, and our random variable X would represent the number of people selected before 10 people were found who attended the last home game. And that's rather a lot to write out, so again, good practice to write that out in an exam, but I won't fill it in here. So X would follow a negative binomial distribution with parameters 10 and 0.4. If you want to play around with plotting some negative binomial probabilities, unfortunately that facility is not available in GeoGebra, but it is available in Excel, and under the statistics functions you should find neg-bin distribution, and you can play around and try different values for R and different values for P, and you will notice a change from quite a positive skew plot to a much more symmetrical plot as the value of R increases. That is the end of this video. In the next video we'll be looking at calculating probabilities for the negative binomial distribution.